Next, we're going to get into a little bit more of how we get into the picture. You know, how we're going to integrate in ourselves and our reality into this picture, and then talk a little bit more about the mechanics of how the reality works. And that'll finish up section 2, and then we're going to talk about the mechanics of the virtual reality. You know, how does this virtual reality actually work? How do we get rendered this way? All right, so we left off with experience being the generation of the data being the information that defines us in our reality system. Okay, now because experience generates that input, okay, consciousness facilitates its own evolution, okay, by breaking itself into pieces and letting those pieces interact. So now think about what you need in order to evolve is choices, right? You make choices and the choices help lower your entropy. Well, now if you're just one monolithic consciousness system, your choices are sort of limited. Your interaction is rather limited. It's not a very complex game you're playing. You know, you have to just play with yourself. You know, there's no little friends to play with. So what consciousness does is sort of what those cells did. You know, it divides. It breaks itself into pieces, and each one of these pieces now is a subset of consciousness. And these subsets of consciousness, just like consciousness, has free will, and they can interact. So instead of one big monolithic consciousness, now we have lots of subsets that are interactive with each other. Suddenly the complexity and the choices go way up because these things have free will. So that's a strategy that the consciousness system can have in order to lower its entropy. It needs more complexity, it needs more structure, more choices. So that's what happens, and we then are these subunits of consciousness. We are these individual chunks of the larger consciousness system that has free will. So now you can begin to see the metaphysical picture starting to take shape. You've probably all heard things like we're all one, you know, we're all connected, and this sort of thing, where you're starting to see how that plays. You know, we're all part of this larger consciousness system. We are subsets of that consciousness, and our job is to evolve, and as we evolve, the whole consciousness system evolves. So it's not just that the conscious system is static and it's just there and we're trying to grow up and be like it. It's that the whole system is evolving, and our personal evolution is part of the system's evolution. Okay, so defining the purpose and direction of that evolution as the lowering of entropy, that also then derives, you know, good and evil. What's productive and what's non-productive. In other words, it's good if it lowers entropy and is in the service of evolution. It's bad if it increases entropy and is in the service of de-evolution. So we suddenly now have good and bad defined in terms of whether you're evolving or de-evolving. Okay. And that, of course, then leads to morality, spiritual growth, love. All those terms we're familiar with in the metaphysical start to come out of this relationship of the larger consciousness system, us as parts, and the point of it all being evolution, raising the quality of your consciousness, which means lowering the entropy of your consciousness. So that's how love is defined. You are, as you evolve in this process, you are evolving toward becoming love. What is love? Love is a low entropy consciousness. That's basically the definition of love. When consciousness becomes very low entropy, it becomes love. So now you have a technical definition of love in terms of entropy. I don't know, that's a strange thing, isn't it? Okay. Physical reality then. Okay, so here we are, all these individuated pieces of consciousness. Now, how do we interact? We're supposed to lower our entropy and grow up. And how do we do that? It's just data. Consciousness to consciousness is just sending data back and forth. What do you do with that data? Well, you can believe it or not believe it. Again, you can't really understand the source. You just get the data and have to interpret it. So you're kind of stuck in a very ethereal world with very little traction on choice. You just get data, and so what? You do with it what you can. So what's needed now is some rules, something that makes the game more interesting, something that provides strategy and choice and ability to grow, more interaction. Well, you know, a game isn't a game until there's rules, right? If there's no rules, the game isn't interesting. It's the same this way. The constraints of rules produce specificity, which produces choice, which lets us interact. So what's needed in this consciousness system is a virtual reality, one that the individuals in it can interact with each other and get immediate feedback with that interaction. It has to be a simple, concrete interaction. So we end up with this system evolving, okay, a physical reality as a virtual reality for these subsets to interact in. So now we get to why we have this virtual reality trainer that we're in, and why it would have to come about. It's necessary for the evolution of consciousness. If you don't have rules, everything is undefined as far as content and purpose. The rules then define the purpose. So where did this digital reality, or where did this virtual reality come from? Well, think in terms of the big digital bang. Okay, and that is, if you are consciousness, you are digital information system, you can start with some initial conditions. You can start with a rule set, and what's the rule set here? It's called physics. It's, you drop things, they fall down. That's part of our rule set. So you have physics as the rule set, deposit some energy, wrap it up in a little ball, then you start the big digital bang, which is like the big simulation, and you just let all that stuff interact according to the rule set. Okay? And when it does, you end up with our universe. Same as the big bang that starts from nothing. This big bang now starts as a evolving virtual reality. So you let all those initial conditions, and you let the physics define it, and the gas coalesces, and eventually you have gravity pulling things together, and you get universes and planets, and eventually you get a place like a solar system and Earths, and amino acids and biology starts, and you end up with people. So it all has evolved itself from the initial conditions and the constraints. The constraints, again, being the rule set, which is the physics. That's the rules that says how this place can operate. Okay, so it's not a matter of somebody having to sit down and enter into a computer every detail of this reality frame. It just evolved. Now, we do that with computers all the time. We have simulations of Big Bang. We have simulations of Earth and when all the masses were together, and of biology and evolution. These things are not all that difficult to simulate. So we do that, but we do it on a very minor scale compared to this. This is obviously a very grand scale, but then we're talking about a very large and, at this point, very bright information system. So then that's where the physical reality comes from, and that's why we have to have it. Because here you have traction on experience. This is a place for experience. This is so much richer in experience than just data passing between minds. It's the difference between being in a dark room with other people that you can't see, but you can only hear. And suddenly somebody turns on the lights. Suddenly you have all this, a lot more information, a lot more data. You have strategies. You have, if you don't lower your entropy, life gets more difficult. If you don't grow toward love, life gets more difficult. Fear is the opposite of love. Fear is growing toward higher entropy. Your life gets more disorganized. It gets more difficult. Things don't work right. So that's why we have this virtual reality. That's why it's necessary. And it's not that somebody made it, it's that it evolved out of this system. So we're just talking about a natural system now, evolving. And I didn't mention it before, but this system is not infinite. The system is finite. All real systems have to be finite. Infinity is a mathematical abstraction. Nothing ever really gets to infinity, even in mathematics. It just approaches infinity. It's an abstraction. It doesn't exist. Real systems have to be finite. Okay, because if you have infinite systems, you have lots of problems. You have to have infinite energy. You have to have all sorts of other infinite things to support an infinite system. And there's no need for that. It only has to be large enough to do what it does. Now, it's a large system, and for all practical purposes to us, it would appear to be infinite. But that's like you floating in an inner tube in the middle of the Pacific Ocean. The ocean would look infinite. It's not, but it certainly would seem that way. And you would float for weeks and weeks and weeks, and nothing would change, and it would seem infinite. So that's the way we are relative to consciousness. It appears to be infinite, but it's not. Okay, so the two things you need to make a game, to make a structure of interactive experience, is a goal, to lower the entropy, and constraints. Those are the two things. The goal defines your purpose. The constraints define your approach, your strategy, your process, how you optimize, evaluations, feedback, logic. All those things come out of constraints. Without constraints, you don't have any of that. Okay, if there were no constraints, there would be no consistency, no guarantee that anything actually was as it seemed, no reliability, and no credibility. Okay, now we're going to talk a little bit about virtual reality. This is just an introduction. We're going to talk a lot more about virtual reality in the next section. The best way to get a grip on virtual reality, it's a hard thing to get your hands around because we just have this belief system that we grow up with that's down at the bone level, that, you know, we are separate beings, you know, we live in an objective physical reality, that sort of thing. So contemplating this virtual reality is a mindful, and I know it's hard to do. Think of it in terms of computer games. If you're under probably 35 or so, you're probably real familiar with computer reality games. Things like World of Warcraft, things like EverQuest. There's others. There's a dozen or so of these virtual reality multiplayer games. And that helps a lot if you have familiarity with that. That helps a lot to understand these concepts. Think about those games where you and a lot of other players have characters, and those characters interact with each other, and they interact with computer characters that aren't run by persons. Okay, the computer runs the setting and its own characters. Your character, okay, is within the objective reality of the game. Okay, that's basically you. Okay, think of that as an analog to that's you in this game, as your character in that computer game. Okay. The server generates the set, enforces the rule set, and defines the characters, the interactions. Right? It also serves as the interface between the characters and the player. Okay? So that then is an analog to the larger consciousness system, would be like the server in these games. Okay, now the local computer stores the character's content, what the character's doing. You know, in these games, there's terms like hit points and things that keep you alive, and skills and talents that you have, and all those things have to be kept track of, and you gain those with experience. So that's going to be on in this case, the local character is going to store that on their own computer. Now, that's not really the way these games work, because the game manufacturers don't want individuals to cheat and change how what their characters can do. So they store it on our server, but we're going to say that that's stored on the cheating isn't an option here. Well, maybe it is, but we'll talk about how to cheat later. Cheating's not an issue anyway. We actually encourage cheating in this system, and that cheating, that storage on the player's computer then is like brain function. That's where all the data is stored for that game. Okay? So the player themselves, you, the player that's operating your character, you're basically providing that character's free will and their intent. You're the one who decides whether they run or fight or go left or go right or open this door or go into the dungeon or whatever it is they do. So that makes you the higher self, the intuition, the guidance, direction, consciousness, oversoul, superego, all those terms that we use, that would be you, okay, in that role. Okay, so that kind of gives you maybe a gut feel of what we're talking about here in virtual realities. Okay, now there are many different realities. All these realities are different data streams. If we're in this physical reality, then we're just a consciousness receiving data. This is how we interpret the data. And it's an interactive game. Okay, it's a multiplayer game. But there are other data streams. Lots of other data streams. There are other realities like this one that are constrained enough to be physical or to be like physical because they have enough constraints to give them that characteristic of being physical. There are those that are less constrained. And the less constrained realities are more like where Uncle Fred goes when he dies. It's not as constrained as this, but it's still a virtual reality. And many people have the idea that, okay, this is the virtual reality, but then when you pass on, you're going to the real reality. That's it. This is the fake one, and that's the real one. It's not like that. They're all virtual realities. All the various physical realities and what we call non-physical are all virtual realities. There is only one thing that's fundamental, and that's consciousness. Just the consciousness system is fundamental. Everything else is virtual. Okay, so what about these various realities? I talk about physical and non-physical, but those two words are really meaningless. That's an easy way for you to understand it because we all know this is physical and that makes all the other stuff non-physical. But actually, what's physical and non-physical is strictly a point of view. When you are in this reality frame, this appears physical because this is where your focus is. This is the data stream you're in, so this appears physical. When you're not in this reality frame, the reality frame you're in seems physical, and this one seems non-physical. For instance, dreaming. When you dream at night, this reality that we're calling the physical reality is not physical. It disappears. It's gone. It's now a non-physical reality, and your dreaming reality appears physical. Now, it doesn't have the same physics as this. It doesn't have the same rule set. So in those dreams, you can leap over tall buildings in a single bound, fly faster than a speeding bullet, and all those things that you can't do here, you maybe can do in your dreams because there's a different physics there. You're not constrained by the same rule set. But that seems physical to you, even if you're flying or doing anything else. That's your reality frame. Seems physical. This reality frame is non-physical. Well, that's the way it is all over. And what that does is it brings us to the really the next level of relativity theory. In relativity theory, Einstein came up with the idea that there was no fundamental inertial frame. Okay, that, in other words, everything was relative as far as platforms moving with respect to each other. There was no absolute inertial frame. And up until that time, science thought that there was some fundamental frame. Of course, we were at the center of it by definition, right? That's the way we think. So there was this fundamental frame, and then eventually it became the ether. You've heard of that. Well, that was going to be the fundamental inertial frame. But Michelson and Morley did an experiment, and the experiment that they did determined that there was no ether. So scientists then, like they always do, started making up excuses of why that wasn't the case, and the ether was dragged along with the Earth, and they had all kinds of other ideas to try to patch up that problem. But Einstein looked at the obvious solution, and that is that there was no ether. And the way Michelson and Morley did the experiment, that extrapolated to the idea that the speed of light was invariant. It didn't change relative to the platform's velocity, and we'll get a little bit more to that. But anyway, to kind of get to where I'm going with this, is that based on this idea that there was no fundamental inertial frame, the theory of relativity was born out of that idea. Well, now the next step is to realize there is no fundamental reality frame. This is not a fundamental reality frame. This is just another reality frame. Your dream reality is just another reality frame. Where Uncle Fred goes when he dies is just another reality frame. There are lots of these virtual realities. They're all virtual realities, and they're all there for more or less the same reason. They're part of the process of us evolving. This larger consciousness system is evolving. We're part of that evolutionary process. It supports the process. So it helps us. It sets things up, gives us the experience that we need, sets up the environment for us individuated units of consciousness in order to make our evolution easier and more effective. So that's kind of an overview of where we're going here. So the way you deal with these different reality systems is that you can move between them just by focusing your consciousness to a different data stream. Okay, now that happens naturally at night. You lose consciousness here, then you off and on gain consciousness within the dream reality. But you can do this intentionally. And it's not, it's not a process that has a lot of physical drivers in it. Unfortunately, people, we talked about that, the out of body, and people are focused on their body. It's just the mind. Just the consciousness switches to a different data stream. And eventually you can get familiar with a lot of these data streams, and you can switch between them in seconds. You don't need to go through a lot of meditation. You don't need to go through a lot of relaxation and all that sort of thing. You can just switch frames. And then eventually you can parallel process, and you can connect to more than one frame at a time. And you can then be living in several reality frames. It's not as hard as it sounds. It's just a matter of training your consciousness to become aware of these other frames. By nature, when we come to this reality, we are, we're kind of centered and focused here because we have a job to do. And it's not made necessarily real easy and obvious for us to hack the system and jump into these other frames, but you can learn to do it in any case. So that's kind of the big picture of where we're going. So these altered states of consciousness, the out-of-body experience, the paranormal things, remote viewing, healing, all that stuff are basically interfaces between two reality systems. They're interfaces between this virtual reality and the larger consciousness system, other virtual realities. Okay, so it's just a matter of perspective. There is no fundamental reality frame. I know we all think that we're in it, and this is the real one, and all the rest of them are imaginary. But all these other realities with all the other entities and beings that are in them, see us as non-physical, if they know we exist at all. So it's that sort of thing. No fundamental. It's a kind of a big concept to get that this is just a reality. Okay. Now, let's talk a minute about past, present, and future. We, in this reality, live in the present. All our decisions and choices are in the present. Okay? Now, our reality is generated, is sent to us, like a simulation. In a simulation, the computer cycles through the code, and it takes it a delta t to cycle through the code, and then it changes variables, and it cycles through the code again, and so on. This works the same way. As Fredkin said, we're in a simulated reality. You think of this as a simulation, and so you have delta t by delta t. We're getting updates, a refresh rate, right, on the gameplay. It's like the refresh rate on your computer monitor when you are playing a game. And if the refresh rate's slow, it's jerky motion. If it's fast, it's nice and smooth. But delta t by delta t, the data changes when we make choices. So here we are in the present. Free will is only executed in the present. We make choices, things change. Next delta t, we get to make more choices. Next delta t, we get to make more choices. And the choices that we make then line up in a row behind us, and that's our history thread. That becomes the history of this multiplayer game. So we have three databases really that I want to describe to you. One of them is the probable future, And how that gets generated is that you have the present, and it's clinking along delta t at a time, right, where we're making choices, but the computer can project what's likely to happen next. So the computer can say, consciousness system being the computer, can say, what's likely to happen in the next delta t? And then they can say, well, assuming we got that right, what's going to happen the next delta t after that, and the next one after that? And it can go out as far as it likes that way, but of course the further out it goes, the rattier it gets, because each time it's depending on the last assumption to be correct. And errors start to propagate. So you can only go so far that way before it doesn't make sense anymore. So we're going to show a plot of that in a little bit, just kind of introducing these ideas, these now. We'll talk about them a little more later. I find that people will get it more if you kind of introduce ideas and then hit them again later than just dumping it once and going on. So we have that probable future database. And this is a very important one because later I'm going to show you how this probable future database defines quantum mechanics. So we have this probable future, which is all the things that might happen. And with all those things that might happen, they're assigned a probability of happening. Okay? So everything that could possibly happen is assessed to its probability of actually happening. And that's what we have in this probable future database. So now you can get into this probable future database and explore around in it. And if you just went from most probable in this delta t to most probable in the next to most probable in the next, you would kind of trace our most probable future. But you can also get off on side tangents on things that aren't probable. It's all there in that database. So that's what feeds it. You can think of this probable reality. It gets down to the present moment. Choices are made. Now, we may not make the choices that the system thought we were going to make. If that's the case, then it has to make changes, propagate just those changes out, the changes that cause changes, and kind of fix that and recalculate, back out our future probability. Well, that's not a hard thing for it to do. So the last database to mention to you is the unactualized history. So those are all the things that we could have done but didn't do. So now all the probabilities that were up there of the things we could do but we didn't become those things that we could have done but didn't. That becomes the past. After that time, after we get to that delta t, then that projection becomes past. So there's our past history thread, the things we actually did. There's all the things we could have done but didn't do, and those all also have a probability assigned to them. Okay, so now this is a very important concept, these three databases. The probable reality, the present where the free will gets activated, we make choices, and the two past. Our history thread, this is the stuff we did. Our unactualized history, that's the stuff we could have done but didn't. Now the two of them, the future probability and the unactualized past, all have probabilities associated with them. Okay, so you can get in there and get into those records. Now, if you have been into metaphysics, you've probably heard of Akashic records. Okay, this equates to the same sort of thing. This is where all the data is, but it does a lot more. It's a lot bigger concept than Akashic records. Okay, so let's go on. Okay, now here's a little picture of how these choices work. A little cartoon. Of course, there are billions of choices, and I'm just looking at three because three are all that I could put on a piece of paper that we could see. This is our system, and I mentioned that our system was our physical universe plus all of that non-physical that interacts with this physical universe. Okay, because that's not all of the non-physical. There's a whole lot of things that are, remember, non-physical is just everything else. We define this as physical and this, everything else is non-physical, just from our point of view because we're here. Okay, so here's OS. And OS right now has a choice between three states. It can go either here, here, or here. So the people in OS make a choice. It's a delta t is upon us. We make our choices. We pick this state. Okay, now as soon as we pick this state, this, and all the probabilities attached to them become unactualized history. Those are the things we didn't do. Okay, we could have made this choice or we could have made that choice, but we didn't. So these all become in the unactualized history database. That is the present. This now becomes the new present. That's the new actualized state. And now suddenly all of this stuff becomes the probable future, right? All those possibilities are the probable future. Well, now we could go to this, or this state, and we pick this one. As soon as we do that, all of this joins the unactualized history, okay? And all of this now becomes the future probable reality, okay? And then we make another choice, and it's the same way. Everything that's kind of in line that feeds from that choice becomes our probable future. Then we may move to this one, and so on, you see. But this is just 3, and I have each thing branching into 3, but we're talking about, billions branching into, trillions and billions to the billion power and that sort of thing. We're talking about a lot of data, but again, this is a big system, finite, but so big that it seems infinite to us. So that's how it grows. That's massive, but that's how the system works, and you kind of get a sense of it, all right, with that picture. Now here's what I was telling you about with the future probability surface. Here's t equals 0 in the center. T goes out in all directions here on a radials. And these are probability functions. Probability, it's hard to see because it's in black, but probability is an arrow going up. And as you get close to the present, there's a whole lot of things that are high probability. As you get out further and further out, it gets scarcer and scarcer. But occasionally, you can go way out, and you get a peak like this one or a peak like this one, and they're pretty high probability for being pretty far out. And if you were somebody who liked to divine the future, those would be pretty good guesses. And they're spiky, so they're pretty precise. You get things like this sometimes that are fairly high, but they're spread out. You're not sure whether it's going to be here or here, and it could be, it's kind of spread out in other dimensions. This is just a two-dimensional, metaphor here, so don't take the cartoon too seriously, but it kind of describes how this works. Here's one that has a lot of uncertainty in time, so it's kind of spread out over a long thing this way. This one has an uncertainty in event, let's say. So it's not sure exactly what's going to happen, but we know it's going to happen sort of in this time period. It's that sort of thing. So this is the way it is. And every delta t, time now, just think of this as a surface, like it was a tablecloth or something, and you're pulling it down through a hole in the center. So every delta t, those peaks move closer and closer to the present moment. They get to the present moment, they disappear down the hole in the center and become part of the past, either the actualized or the unactualized past. So this is this is kind of the idea of how that works. Okay, next. All right. Some big picture issues. What about the past and the future? Can we visit it? The answer is yes, we can visit it. We can get into those past, both the actualized and the unactualized. But now what's in there? What do we see when we go in there? We see something just about like we see now. We see something that when we're in that looks like it's physical and it's real, and we can do what-if analysis in there, but there's a difference. When we are in those reality frames, the characters in there have no free will. They're just models. They're models of us. Well, you'd think, well, see, that's weird. Models of us, that must be hard. How do you model me? I'm a real strange person. That would be hard. But it's not that hard when you think about what are you to begin with. You're a collection of data and rules that define you, your entropy, your intent. So you already that, but you have free will. You make choices, but again, that's in the present. So if you go into this past database, let's say you go back wherever you want. You can go back to ancient Greece and see, how things were then, and you can get into that database and wander around. And because it's all designated by probability for every event that could happen, you have the probability. So if you go back there and say, well, what if, we did this instead of that? Make a change, and you will then follow. The script will change, and you will follow that line of probabilities. You'll trace out that path. Okay, now you can do that in our history thread, or you can also get into the unactualized history, the things that never happened here, and do the same thing. So that data is all available to you, and you can interact with it as you will. You can do the same with the future. Where do precognitive dreams come from? They come from people whose conscious awareness wanders into the probable future database. They collect information there, they see things, they interpret it, they bring it back, and those things will happen if it's a precognitive dream. That's where it comes from. Now, do those things have to happen? No. We have free will. We don't have to do the expected. But is it likely those things are going to happen? Yes, if they happen to follow along a thread that was most probable. Now, if they're on a thread that's improbable, they can see it and it doesn't happen. So that's the dreams of the future that never take place. You know, you're not, either probabilities have changed or you weren't into the most likely reality frame. So you can see it's a little bit tricky getting around in these frames. You have to kind of know where you're going, what frame you're in, and how they work. Otherwise, you just stumble around and you could be getting data from who knows where. You don't know what you're into. So it takes a little practice to understand these frames and be able to extract data from them. Well, how do we extract data from them? We extract it with our intent. The query system is by intent. Intent is the prime mover of consciousness. Okay? So intent will manipulate these databases. We're going to get into more of this later. This is the last line, I guess I should say, because we're going to hit that later too. And that's that the future exists in probability and remains that way. Unrendered. When it's in that probable reality, it's unrendered. The system doesn't have to render, obviously, what hasn't taken place yet. And it only gets rendered when we make a measurement, when we do it. Okay, now you'll see how that ends up giving us quantum mechanics a little later. Okay, the larger reality system is teeming with life. We are not it, and we are not the center of it. Many virtual realities, most of them are populated with all sorts of beings. All of them are basically in the same boat we are, and that is their purpose is to evolve. But now you can evolve positively, you can evolve negatively, you can de-evolve, evolving negatively. But there are you can decrease your entropy in both directions. Okay, now that's maybe a little confusing. You can decrease your entropy in a negative direction for a limited time, well, I shouldn't say limited time, but for a limited degree just by control. Okay? If you can learn to control your mental function, then you can get into these databases, you can move in other reality frames, and you can do that with negative intent. Okay, so that's kind of the origin of, you might say, evil, or those entities that we run into that are not friendly and not helpful. They, through control, can manipulate their intent enough to move consciousness. Consciousness moves by a focused intent. Okay? The problem they have is that being higher entropy beings in their interactions, even though they can force a low entropy interface with consciousness, they tend to be self-destructive. It doesn't work out. They can only evolve so far. You know, it just doesn't go very high. Whereas on the other side, it's basically limitless. You can evolve and keep right on going. There's no ceiling. On the negative side, you can gain some power, you can do some things there, but it's self-limiting. Because of their high entropy characters, even though they get a low entropy connection to consciousness, they're limited in how far they can get that way. So it's a stunted growth. But they can grow, and that's why you have people doing, negative things with this consciousness system. You have, the classical things, voodoo and other things like that, people making each other sick or hurting each other or sending bad thoughts and that kind of thing. That works too. It's a fair system in the sense it's open to free will. So free will can choose well or can choose badly. But choosing badly is very limited. You either de-evolve and work yourself into a hole, or you have to use control for a very limited gain in your ability to manipulate consciousness. Okay, this is a cartoon of the way I found the larger reality to be. Here we are in our universe inside the green line. OS is the red line. And then there's all these other things. These are PMRs, which means physical realities. And I start them here with 1, 2, to K. And then there's these other things that aren't exactly like physical realities, but they aren't exactly like what we think of as the other side, the less constrained realities. But we're all inside of this big thing here, which in my books I just call it N division. But these things seem to be more political and kind of different experiments in consciousness, if you will. So here, with this PMR, we have a certain history going and a certain level of success in developing consciousness and evolving it. We have our own rule set. We have our own rules out here in OS and in this whole N division. These others have their own rule sets, their own different physical realities with different physics, different ways they operate. When this consciousness system decided to divide and conquer, to make itself different so that it could interact and therefore evolve better, it did a lot of different experiments. It tried a lot of different things. What didn't work got deleted, got let go. What did work progresses and continues to evolve. And it's been broken into these systems. Now you can go from one system to another. You can visit these various systems. It's able to incarnate into these various systems, but it's not done that often. Mostly beings stay within their system because it's what they're familiar with. It just happens to work that way. I've been to maybe a dozen of these different things, and there's not a lot of interface between them. There's some. They have different rules, different cultures, if you will, different ways of going about what we go about. It's sort of like going to a foreign country, with a different culture. It's that sort of thing. So that's just the organization that I find. Now inside of this N division, inside of this, there's many realities. This little diagram doesn't show you there's hundreds of these realities in there. There's not like 5 or 6 like shown there. There's hundreds of realities in there. So the bigger reality is really full of life, full of beings, all trying to evolve in different situations under different rule sets in different ways. Some of them being more efficient and effective than the others. Of the ones I've been to, this one seems to be somewhere between a lot of rules and there's some that have more rules, some of course that have a lot less. This seems to be a very popular and a very good system. So other places I've been have not been as friendly as this, but then I guess everybody feels that way when they go visit another culture, right? You always feel a little ill at ease and a little out of your depth because you don't understand what's going on when you go to these things. Okay, we'll talk a bit about rendering virtual realities. It's a finite system, this larger system. It has to conserve its resources. It does not have infinite resources. It has a lot going on. Okay, it's a multiplayer virtual reality system, but the setting is rendered as required. And we're going to get into a lot more detail in the next section, but for those of you who play these games or have watched your kids play these games as I have, you notice that when the character turns a corner, suddenly some trees and mountains pop up in the background. Well, the reason those trees and mountains pop up in the background is because there was no reason to render those for that character until that character turned the corner. And because the delta t refresh time isn't fast enough, then the character actually gets to see the mountains and the trees, pop up in the background. So that's why that happens. Well, we do the same thing, except our graphics are much better here. So we don't see them pop up in the background. They come up. The delta t we're talking about is like a nanosecond. Like a 10 to the minus 18th or something of our second. So it's so small that we don't see that time isn't continuous. It seems continuous to us, but it works the same way. There's no point in rendering something to an individual's consciousness. Remember, we started a long time ago and saying all reality is individual. Okay, well, there's no point in rendering something to your consciousness, that you're not measuring, that you're not involved in. So that doesn't mean that it doesn't exist. It means that it's not rendered into your consciousness. So you only need to render the reality into the consciousness of what the consciousness is experiencing. That's all that needs to be rendered. Anything else would be a waste of resources. Why make those mountains and trees take up computer cycles to keep them there all the time when there's nobody looking, when there's nobody in that area to experience them? Well, the server running these games can't afford that. It can't be making all of the scenery all the time, even when there's no characters in the game. It only makes them when there's somebody there that needs to see them. Our reality works the same, and there's some very interesting logical consequences of that, which we're going to see in a little bit. There's some physics that this answers, the question why it works that way. So we'll get to that. Let's see. The system knows, because it has this probability distribution of everything that's going to happen, or probably will happen. So it knows what's coming for the most part. Of course, we sometimes mess it up by making decisions and choices that it didn't expect. But we mess it up less than you think. We're pretty predictable, particularly if you have all of our history, every thought, every idea, every feeling that we have ever had in this lifetime and all the others as a consciousness. All the data is part of the record. That makes us pretty predictable. We don't change that much from time to time. From delta t to delta t, we don't tend to do big changes. So we are all very predictable. That's why you get into these databases, and it's just like being here. All your characters there are just you without the free will, basically. And you can process through the probabilities. So anyway, that's kind of the big picture of how things work here. Next. All right, so let's talk a little bit about the nature of virtual reality. Let's imagine there's a planet, and this planet, I call it Planet Z, but this planet has people on one side. It's a big planet, about like ours, and has all the trees growing on another continent on the opposite side. Okay, and the people on the one side have never gotten off of their land. They don't go very far out into the water. They can't swim, and they evidently don't have good boats. So they're there. Okay, so now there's this kind of problem that comes on. All the oxygen's produced on the other side of the planet. Now, does the other side of the planet have to be rendered in order to give these fellas oxygen? No, it doesn't have to be rendered any more than oxygen has to be rendered in this room. It doesn't have to be rendered. You only have to render the effects, not the thing itself, unless you're looking at the thing itself. Okay, so this is a hard concept to get, so we'll kind of spend a little time on it. As long as it is probable that those trees would be there, then it's probable that there would be oxygen in the atmosphere, then it's probable that these beings can live over on their planet just fine. And no oxygen ever needs to be rendered anywhere. Matter of fact, that whole half of the planet doesn't have to be rendered. Does that mean that now you don't render that planet, it'll start to wobble because half of its mass is gone? No, you're thinking physical. It's not like that. All of it is just data. There is no physical reality. It just appears to be physical from the data and the interpretation you give it. You don't have to render anything that isn't being experienced. All reality is personal. Okay, these kind of a lot of big ideas, and they're coming together. They're kind of hard to get a grip around them, but you only render what's necessary. Now, we as scientists do this all the time. If I'm going to do a simulation of anything, of wind blowing a tree, and it's, how much does the tree bend in the wind? Well, do I start with modeling all the molecules of gas in the air? No, I don't bother with that. Would I have to model the atoms that are in the molecules? No, I don't bother with that. I specify a wind velocity. I specify the size of the tree. I specify the drag force between the two. And I run a CFD, that's a computer program, a certain kind of computer program. And I compute how much the tree gets blown over because I know the bending moments for the tree, for wood, and that kind of thing. But I just simulate it in terms of pressure, wind velocity, those kinds of things, sizes. I don't have to do atoms and molecules. I just have to do the effect of atoms and molecules. You don't have to model all the details. You just have to model the effects. Well, that's the same way in this reality. Only the effects have to be modeled. Now, right now, we're in here. Nobody has to model oxygen. Well, we all believe that it's in here because we have to breathe it, and if we wouldn't breathe it, we'd die, but that's our belief. It doesn't have to be modeled because the effect is modeled. You only have to model oxygen when somebody's looking at oxygen. So if you do an experiment and you put a wire in water and you run a current through it and you get oxygen and hydrogen and you put them together and light a match and it goes boom, now you have to have modeled oxygen because you've done something that needs oxygen as an objective thing in your environment. So it's a hard thing to think about, but that is the way it works. Okay, now you look in these simulations, like if you look at World of Warcraft, you look at The Sims, it's more of a girl's game. You look at these things and the players there, if they fall into a river or fall into a swimming pool and don't know how to swim, they drown. Why is that? Because they couldn't get oxygen? No. Obviously, they're not modeling oxygen. They're just modeling the effect. Their rule set says that people can't breathe underwater. Therefore, if you stay underwater for more than a certain amount of time, you die. They've modeled the effects. They don't have to model water or oxygen any more than we do. They just have to model the effects. Also in these games, if you fall off of a cliff, it might kill you or it might just hurt you. Depends on how high the cliff is. Well, these are just computer characters. Where's gravity? Do they model gravity? No, they don't have to. They just model the effects. So that's just the way it works all over. So our sense of physical realness is an illusion. What's probable, according to our rule set, is enforced. Consistency is required. Once something comes into this reality, it has to stay in this reality and abide by the physics in this reality. You can't have things popping in and out, right? So once you do notice those little particles going through the slit and you've measured them and they're real and they're in this reality, well, all they can do is go on a straight line until they hit the screen behind the slit. They have no other choice at that point. Okay. But if you're not looking at them, if you don't measure them, then they don't have to come into this reality until they've already combined through two slits as probability and make a pattern on a screen, because that's where you take the measurements. You see how this works? And the reason that they're probability distribution is because that's how our present, that's where our present comes from. It's this is probable future that one delta t at a time kind of drops into the present and we actualize what actually happened there. Okay. Now, one thing that's interesting here is that the uncertainty in whether something exists or not, or how something comes out, produces some wiggle room. And within the constraint of that wiggle room and with a thing I call the psi uncertainty principle, you can use your intent to modify what happens. And that's what we do with healing. That's what we do with good luck. That's what we do with a whole lot of things, and we'll talk about those. Talk about some of those a little later. Okay, I think we talked about this. Details aren't rendered. They remain in the probable future database until a measurement makes them necessary. It saves computer cycles. Why compute things that are unnecessary? Now, we don't really notice so much here. We do notice at the micro scale, but we don't notice here, but that's because we're really not looking. There's a couple of events that are on this macro scale that we can verify this model with, and we'll talk about those. It's true of all particles. It's not just funny particles like photons. It's all particles. All of our matter is basically probability until there's a measurement. At the measurement, it has to come into being. Once it's into being, the reality must be consistent. That's one of the rules, consistency. We have to have a consistent reality. So we've seen this chart before, but now it should start making more sense to you, that explanation that I gave you before. So now we're seeing that this probability distribution that we have around this particle is simply the fact that that particle is in the future probability database. That's where it is. It hasn't happened yet. It hasn't been measured. It doesn't have to be rendered into this reality just yet. Nobody's looking at it. It's just theoretical. It just is out there somewhere as a probability of it. Now, in this probability database, there are some things that are more probable than others. And when you make a measurement, you get what's most probable. That's how the wave function, this probability wave, that's how the wave function collapses to whatever is the most probable thing at that moment to measure. So here we are, and it's probability. It gets measured. It's a particle. It's in the present. It goes in straight lines. Here, it doesn't get measured. It's still in the future. As a future thing that has to interact here because it has been shot there, right? From a past state. It's headed in this direction. It hasn't gotten to this yet. This is going to be its next measurement in the present. So it's in process of getting to where we're going to make the measurement. It's just probability, so it passes through both slits, combines its probability, and makes this thing. So we see the difference here is that that's the present, this is the present, and it doesn't matter about whether you leave these detectors on or not. It's measurement. It's where you take the measurement, and that's why that Wigner and Einstein and the others knew that consciousness was involved. See, this is where they got that idea, because they would leave those detectors on and they'd basically, cover their eyes. They weren't looking, right? The consciousness was not observing the experiment, and they'd get this picture. And then they'd turn their data recorder on and record the data. They'd get this picture. And they realized that the difference was them. They were influencing the result of the experiment. They were, whether they looked or not, whether they made the measurement or not, determined on how the particle, was it a particle or was it a wave? Well, what they didn't understand is they were moving the present from this place to this place. That particles are all in a probability space. That's where our whole future is, in probability, until we actualize it. Well, actualizing it is another way of saying, take a measurement. We do it. We take the measurement. So when the measurement's taken, it's here, and then it needs to be consistent. So this is why quantum mechanics is quantum mechanics. This is why particles are probability. There's no other way for them to be. They remain probability until measured. All right. Here's another little interesting experiment that has been done many times. There's an appearance of backward causality. And one of the first times it was done in an Israeli hospital. It's since been done with decaying radioactive substances, and they get the same result. But I'm going to go over the one with the hospital stay. You'll find it real interesting. I think it was a group of rabbis and other people who were interested in metaphysical things, and they collected data from a local hospital of all the people who'd been there over a length of time, over the last 10 years or something. Then randomly, they selected from this data a group, let's say half of them, and the other half then were the control group. So they just randomly picked people out. Then they prayed for the health of these people. Okay, they focused their conscious intent, okay, in my terms. And they did this for a while over these people. Now this is data that's 10 years old, okay? This is old data. So they then prayed for the health and well-being of these people. And then what they found out was that the people in their experiment group that they had prayed for had a statistical significant difference of shorter hospital stay. Those people that the intent was applied to had I think it was it was enough percentage difference to be statistically significant. And that was like, wow, how did we do this? Now this was old data, how did we affect this? So they tried it different ways. They would take another set of data, randomly do that, and this was done a dozen times. And every time they got the same answer. The group that they applied their intent toward having good health ended up with a shorter, on the average, shorter hospital stays than the control group. And it was like, wow, we're changing things in the past. This is backward causality. Well, it's not backward causality. They're not doing that. They're not doing that at all. A similar thing was done with radioactive decay. They took radioactive decay, and if you can imagine a radioactive substance, and it kind of randomly spits out particles. You don't know exactly when these particles are coming out. It just happens. So they use a Geiger counter or some way to intercept this radiation, and they look at the time intervals between getting a reading of some particle coming out. Well, then they take a lot of data. You can take hundreds of thousands of these points of data, and you can average it, and there's some average time that it takes between particles. Well, they would do the same thing as they did in the hospital. They'd take all that data, they'd separate it into various pieces, and they would have people with their minds intend for that data to be a little above the average, it took a little longer, or a little below the average, came out a little shorter, and they found out they could do that. And this experiment has been repeated many, many times. So they can actually shift the average a little. Not a lot. It has to be within what is reasonable. Science certainty principle, not going to let you shift it, but so much. And here's basically the way that works. Let's take the hospital thing first, and let's say we have 20,000 patients. Okay, and let's break those 20,000 patients into 20 groups of 1,000. Okay, now let's take those each one of those groups of 1,000 and break them in two. So now we've got 500 and 500. Now the way it worked is that then they prayed for, say, that 500. And if it turned out that the average hospital stay of the group that didn't get prayed for then tended to be a little longer than the average stay of the one that did get prayed for. And the difference wasn't so much that it would be remarkable for that group. The difference was maybe, 2 or 3%, 4%, something like that. But then they did the same thing in the next group, and it was a few percent, and the next one, and it was a few percent. What you would expect is some of them would be a little high, some would be a little low, because statistically, you're not going to get to hit an average directly. That average could be calculated to 10 decimal points, decimal places. So you expect to fall a little bit to one side or the other, but you'd expect this often to fall, to the high side as you would to the low side. Well, they fell, as far as hospital stays, to the low side 20 times in a row. So none of them were more than probably, 3 sigma events. Well, that's not a big deal. Statistics will sometimes give you a 3 sigma answer, but 20, 3 sigma events, now suddenly you got something that's 1 in 100,000 of happening. Well, that's like, flipping a coin 20 times and getting 20 heads. It's unlikely. So that's basically the way this experiment worked. Well, what was going on here is that present intent, right, can affect those future probabilities. We talked about that. That's how we do healing. We do a lot of things that way. This data had never been looked at for its statistical variations. Okay, so this data was just a set of data that had been taken. Now, as long as nobody had measured that data that they pulled out, they could do this. As soon as somebody, they tried the experiment where they took their patients And then somebody looked at the data that they had randomly pulled out for their patients and computed what the average was for hospital stay. They could have no effect. No longer could they bias it, okay, because now the data had been pulled into the present. Well, this was old data, but it was old hospital records, but knowing what the statistics were in those hospital records, particularly among those patients that got pulled out, had never been computed before, so it was unknown. That was a future measurement that hadn't been taken yet. So the results of that measurement were still in the future. So that's why they could manipulate it. It's the same with the radioactive decay. It was just data. Nobody had looked. Now, nobody had looked at the average, and nobody had looked at the statistical variations of the samples. That means there was wiggle room in reality for that to come out different ways. Now, it always had to come out for each individual sample within the limits of statistics. Like I say, a few sigma here and there is not unusual. What's unusual is that you can always bias it in one direction all the time. That's what's unusual. So the reason that works, and this is pretty much standard people know that this works and this can be done. That's pretty standard. Well, that's why, because that data was still in the future. Understanding that data, the results were still in the future. So until you make that measurement, you can affect things, even things like that. Now, did that mean that there were suddenly some people that got healed earlier than they would have? No, nothing changed. It didn't change anything at all. All you did was modify the statistical outcome of that data by a little bit. Nothing changed. You had no backward causality. Nobody suddenly got better 10 years ago. That would have violated the consistency rule. All that happened is that the statistics stayed within the normal, stayed within the realm of credibility. The only thing odd was that they had all of these things biased in the same way. So it didn't violate any rules, it didn't violate any consistency, nobody got healed early. They didn't have that sort of an effect. What they were affecting was the outcome of the measurement. And we can do that, like I say, with atomic decays just as well. We do this all the time. That's this wiggle room I'm talking about with uncertainty. What about those of us that really, really like our automobiles? We really love our cars. Sweet old Betsy, she always gets me where I need to go, this sort of thing. And you talk to your car, and your car you think is running out of gas, but you say, "Come on, Betsy, just get me just down the block, and I'll treat you to a lube, But you say those kinds of things. You have an emotional relationship with your car, and most of the time, old Betsy gets you there, doesn't she? Times when you think she might have failed, she gets you there anyway. Or you have this picnic that's real important to you, and you don't want it to rain. And you have a whole lot of people thinking, "Oh, just keep the rain away." And it does. Well, we think, well, that's just luck and a circumstance that happens. But if you've had much experience with that, you know that there's dimensions beyond luck with that. And in fact, this is what makes luck. There's wiggle room in there. The measurement hasn't been taken yet. An intent can modify the probability. So if you have that same car and you have the driver who dislikes that car, damn car, it never does what I want it to, and who's always has that kind of an attitude toward it, well, that's the car that constantly fails, constantly runs out of gas, constantly, throws a belt and does other kinds of things. It's the same way. He's biasing the statistics a little with his intent. So a lot of the luck we have, so-and-so's just really lucky. Well, so-and-so has a real positive intent, and they're biasing the statistical outcome in their favor. And so-and-so is real unlucky. Well, generally you're talking about a negative intent. They're biasing the statistics against themselves. So there's a lot of this the same thing as the backward causality thing, where you have a measurement that hasn't yet come into the present, it's still in the future, you can bias that with your intent. There are those people that are in accidents and they survive when nobody should have survived. There's everything's bent and twisted and destroyed all around them, and somehow, all they have is a bruise, that sort of thing. Well, that's because how that metal bent and how it did all those things hadn't happened yet. That was in a probable configuration. Strong intent can make a difference of how that metal bends, how that turns out. So, that gets us back to this, the theory of positive intent, right? A long time ago, Vincent Peale, was the power of positive thinking. And now you have the people who are talking about the power of attraction, or the law of attraction, where it's a similar kind of thing. There are ways in which you can manipulate that probability with your mind. That's also how we heal. We heal by changing the probability of the outcome. If that outcome is not yet measured, not yet certain, we can affect it much more readily than if there's been measurements done on it and it is certain. So that's another little piece of science that gets an explanation with this. The psi uncertainty principle basically says how much variation is allowed. So those hospital patients, it's not like they could have prayed for those 500 hospital patients, all 500 of them turned out, were checked out in an hour. That's not going to happen. That would be a violation of the consistency of our reality. Science certainly doesn't allow it. But yeah, it could be a few percent this way or the other. So we make our own luck as we make our own reality. Okay. And this is, this thing about virtual reality, if you look at the stars, well, the only thing that has to be rendered to you is a little point of light. That's pretty easy. You don't have to render, a gas nebulae and, all of the detail. You only get rendered what you need. When you drive that car, there's no need to render an engine. It's in there. It's probably there because the people build it and you bought it and whatever. So the probability is that it's there. It's in the probable reality. But if you open the hood, then it has to be rendered. If you close the hood, all it has to do is make a noise and get you where you're going. It just has to work the way it's probable for it to work. And if you've had it a long time and it's probable that your belts are going to break, then your belt will break. But again, you can influence whether it breaks, yesterday or today or tomorrow a little bit. You can bias those kinds of things. So you only have to render what's needed at the time. All right. Now that gets us to, we're almost at the end of this section. Let's talk about relativity for a minute. Relativity is based on just one thing, and that is that the speed of light is invariant with the motion of its source. And what that means is, and physicists were startled by this, everything else, velocities add. So if you're on a railroad train and the train's going 100 mile an hour and you throw a ball at 50 mile an hour in the same directions the train's going, that ball's actually now going 150 mile an hour because it's the 100 mile an hour of the train plus the 50 mile an hour you throw it, those add. If you throw it the opposite direction, it's only going 50 mile an hour because you're throwing it back 50 mile an hour in the opposite direction of the train. Well, that's the way things worked, and that's the way physicists thought everything worked. And then they got the light and the ether and the Michelson-Morley experiment, and what they realized was that no matter what speed the platform's going, when you throw off some photons, you throw off some light, it always goes the same speed. Whether you throw it in the same direction you're moving or the opposite direction you're moving, it makes no difference whatsoever. It always has the same speed. And that was the thing that Einstein got from the Michelson-Morley experiment. Everybody else got that, well, maybe the ether's dragging along behind the planet or something. All the excuses that people make to make their theories work. Well, Einstein looked at it and he said, no, it looks like the speed of light's invariant. It doesn't matter which way you're going, it's always the same thing. And he thought about that a while, and up came relativity. That's what relativity is based on. Matter of fact, relativity is mostly just algebra. It's not even very complicated math to get there. All you need to get there is just that one idea, that speed of light's invariant under the motion of its source. And that gets you relativity. And then once you have relativity, all kinds of interesting things pop out. If this little pen is going in this direction, and as it gets faster and faster, guess what? It gets shorter and shorter. It shrinks in the direction of its motion. Guess what else happens? It gets heavier and heavier. And by the time it gets to the speed of light, it gets so short it disappears and it has infinite weight. Well, that's a problem. But that's why things never get to go quite the speed of light. They always have to stop before they get that. They always have to slow down before they get that fast, because then you get to a singularity and the equations break down. But anyway, that's one of the things. That's called length contraction, and the fact that mass increases. That was the thing that leads to E equals mc squared. It was that mass increase thing, the equivalence of energy, the energy of motion, kinetic energy, and the mass. E equals mc squared popped out of that. And then there's a thing called time dilation. Time dilation says that the faster this thing goes, it gets to the speed of light. Time on this thing slows down, gets slower and slower. So you have, a rocket ship, you have two twins. This is the twin paradox. You put a twin on a rocket ship and it goes very, very fast, close to the speed of light, and comes back very, very fast, the speed of light. And the twin gets off and he's younger than his twin. He hasn't aged as much because he's been traveling very fast. Okay, that's time dilation. All of these crazy things came out of this one idea that light is invariant. And that was what Einstein said. And when he first said that, people didn't believe him and thought that, that was crazy. But eventually they actually sent things flying around, little atomic clocks, and brought them back. And sure enough, time had slowed down. They had fewer ticks than the one that was here. And sure enough, in cyclotrons, mass gets heavier, the faster it goes, and things contract. And all of that has been experimentally verified. That's all fact. Today, physicists have no idea why the speed of light should be invariant, why it should be the one exception. Well, here's why. Okay, if you're going to make a virtual reality game, there's two things that you have to specify first before you can do anything else. And one of them is you have to look at the resolution. Now, resolution is what we talk about if we're talking about photography, the resolution, but it's also it's the pixel size. It's how tiny your dots of data are, right? That's the resolution, how small your pixel size is. The other thing that you need to specify is the frame rate. In movies, we talk about frame rate. It's how many pictures you get per second, right, that go by. A movie's really just a series of stills that go by quickly. And if we're talking about a TV or a monitor, it's the refresh rate. How often is the screen updated with the information? So those are the two things. And the reason why you need to know those is that this resolution tells you how much data you're going to get, right? The more resolution you have, the more pixels, the more data you have. You have to have bits of data for every point, for every pixel. And the frame rate tells you how often you're going to have to send all that data out to the display. So it specifies the quality of your graphics and how big a crunch computer you need in order to run a simulation. So those are the two basic things. Well, in a virtual reality, it's the same thing. We have a pixel size, which, because we're a 3D, it's a quantum of volume. Okay, we have a quantum of volume. That's delta V, and I spell it out here because I know there's some mathophobes that if you write a little delta like that in a Greek symbol, they can't understand it, but if you spell it out in words, it's perfectly obvious. So I spell them out too. You have a frame rate, which is one quantum of time. That's a delta t. Well, what's that mean? That means that here's a pixel. Call that a space-time reality cell. Okay, this is conceptual. This is just a concept now. There is no such thing as space. Space is just an idea. It's a rule set for individuals like us to play in so that we can evolve. So this is conceptual cells. But how do we define it? We say, all right, here's this little thing of volume. And the physicists, by the way, they do find that called a Planck's length. It's a little length. Planck's length cubed then is a volume. So that would basically be your delta V, your quantum of volume. And the frame rate means how quickly do you update? Well, okay, if you have information here and you want to pass that along to the next cell, to the next, to the next, you have something moving right through here. How fast can that do that? What's the quickest way you can get it through? Well, every delta t, you can move it one cell, right? You can't move it 10 cells every other delta t. You can't move it different things. You have to move one cell at a time. That way you have consistency, you have continuity. You can't jump around. That would make a kind of a crazy reality where things jumped around. So that's as fast as you can go. Well, what is that? It's basically this length, Planck's length, so it's the cube root of the volume, over the rate that the simulation gets updated. That's just the loop. the loop rate, right, in your simulation. Every time you pass through the code, it's another delta t. Gets incremented. Well, that's c. Delta v, this increment of volume, has to be the same. Otherwise, your reality is strange and it wouldn't fit our rule set. If that delta v wasn't a constant, you'd have a glass over here and it would be half full, and you move it to a different part of space and it would suddenly be, overflowing. Volumes would be different. Well, that's not the way it works. We have to have this homogeneous isotropic space in order for our rule set to work in. That's the nature of our rule set. So according to our rule set, you can only take information from this cell to this cell in a delta t, to this cell to this cell in another delta t. The delta v has to be constant. The delta t has to be constant. Otherwise, time would be jumping around on us. So you have to have c as a constant. So because this is a digital simulation, because we have a delta t that's incrementing us, because we have this uniform delta v's, you have to have a constant c. It doesn't have anything to do with the moving of the platform. It's just obvious that it has to be that way. So now that derives relativity. So in the little picture, a toe is that thing that is that overarching understanding that lets you understand both relativity and quantum mechanics. Well, we've solved that problem. We can show how quantum mechanics works, why those particles are probability distributions, and we can show why, relativity works, why c must be constant. It's the nature of a parsimonious digital virtual reality. It has to be that way. Okay, so that derives both of those. So basically, now that we've dispensed with little picture toes, we can go on to drive the larger reality. Okay, so relativity falls, I guess I've covered most of this. It boils down to, as I say here, one or two of these three things must be specified as constants. And the three things are the shortest time between cause and effect. That's a quanta of time. You have to specify that. That's the loop rate in the simulation. You have to specify the resolution of the graphics, the scene generation, and that's a delta v. And the third constant is c, which is basically the maximum speed which information can be transferred. Okay, those are the three constants. And if you pick any two of those, or if you specify any two of those, the third one is derived from those two. So that's really the understanding of relativity. And we have to have this uniform, consistent space. That's the way our rule set works. Okay. All right, let's do a little summary here. We're getting close to the end of this section. Okay, summary. Modeling consciousness as a self-modifying digital information system that evolves towards states of lower entropy. That's the big one, right? Physical reality is a virtual reality, a subset of the larger consciousness system designed to help budding individuated units of consciousness, us, evolve, lower our entropy. Okay, and we do that through experience and interaction with other entities with free will. Okay, and out of those things, we have some results. Physics and metaphysics become parts of one logical theory and are thus unified. Eastern philosophy, theology have been integrated with science. Love, spirituality are both defined in terms of entropy. Spirituality, spiritual growth is the same as reducing the entropy in your consciousness, raising the quality of your consciousness. Normal and paranormal are unified as ordinary artifacts of interaction within and between reality frame perspectives of the larger reality. The fundamental purpose of existence in general and our existence in particular is derived, and that is to evolve our consciousness, to grow spiritually, to become love, however you want to say that, become one with all there is. There's lots of ways of expressing that same thing. And time, relativity, and quantum mechanics have been defined from one set of fundamental principles with basically two assumptions, and that's consciousness exists and evolution exists. Okay, some additional results. I'm just going back and picking up all the main points we went through. Lowering entropy increases the energy, the power, information available to that evolving entity. Remember, as you get higher, better organization, you have more ability to do things, to affect things. Let's see, I think we did this. Love is defined as a fundamental expression of low entropy consciousness. The larger conscious system is aware, an evolving system. It's real and therefore finite. We mentioned that. Lowering entropy is the same as spiritual growth, is the same as increasing the quality of consciousness, the same as growing up. You know, all these things are the same. We are individuated units of consciousness, a chip off the old block. We are a piece of the consciousness system. All reality frames are part of the same consciousness system. All are connected and all are virtual, except for consciousness itself. It's the only thing that is fundamental. And that there is no difference between physical and non-physical. You can think of everything being physical. Oh, my dream reality is physical, this reality is physical, you know, all the reality is physical. You say they're all non-physical. Makes no difference. Physical and non-physical are just the next relativity. It's all a matter of the observer. It's relative to the observer, what is physical and what is non-physical. Okay, consciousness and brains. Consciousness, okay, is the fundamental thing. That's the superset. The physical reality is the subset. So consciousness leads, the body follows. That's kind of a general rule of interaction of us in our reality frame. Okay, consciousness leads, the body follows. Okay. Now, the brain cannot create consciousness because the brain's physical. The brain is a virtual brain because we have virtual bodies and a virtual reality. Okay, and it only needs to be rendered when we look at it and we bust someone's head open, we need to render a brain. But until then, we just act as if you had one, right? It's not really there till somebody, it doesn't have to be rendered until you see it. Okay. Now, some examples, some science, some examples of how this works. You've all heard of the placebo effect. Okay. Now, the placebo effect is that you give somebody good reason to feel better, and they do. But it's deeper than that. It's not that they just think they're better and therefore tell you that they're better. They actually get better. So if you give them that sugar pill or that pep talk or whatever it takes, and they have this positive attitude, oh, I'm going to take this magic pill and I'm going to get better. They do get better. It actually changes their physical system, and this has been done over and over and over again. The placebo effect is real. It's not that it just makes people think they're better when actually nothing's changed. It's not a psych-up thing. It's real. It changes things. Again, you're using conscious intent to work in the margins where the uncertainty is to produce effects on future measurements. That's the way the system works. Another thing that I have down here, sheep morality, and I didn't talk about it one time, and the first question was, what was that on your slide about sheep morality? You know, that's a kind of an odd thing, but where I got that was from the internet. Some scientists were completely confused as usual. They had things just backwards, and they had noticed that sheep had a morality in their behavior, and that is that if the parents were not around, were killed, say, or taken away from a newborn lamb, that the other mothers would come in and nurture it. They would nurse it and they would take care of it. Now, there was no advantage to them to do that. They were sharing the milk that they were producing for their own lambs with this kind of stray, but that they would do this. And there's other creatures that also have social habits where they take care of each other. And the scientists then, wondering about that, knowing where this kind of behavior came from in humans, they looked at the brains. So as they looked at these sheep brains, they found this part of the brain that was developed that is associated in humans with morality, with moral decisions. And they said, well, see that the sheep developed this brain, which then allowed them to develop this part of their brain somehow, just by chance, I guess, which allowed them to be moral. Well, it doesn't work that way. The sheep develop morality. They develop caring for each other enough to take care of each other's young and to do other things because they're social animals. And that they developed that, created that part of their brain to mirror that. You see, it was just the other way around. We do things and it affects our physiology. It affects our brain. So now let's look at this in maybe a scarier sense. I guess I have that on the next chart. And that is, if you have an experience that is a terrible experience, and maybe it's even just an imaginary experience, like you go to a horror movie and you see terrible things. Horror movies, they're all the same. Some guy with a chainsaw and a bunch of girls in bikinis, right? That's a horror movie. So you go to that movie and you see horrible things, and that affects you. That experience will change you, and as your consciousness changes, your brain changes. You will actually interpret, if you will, that experience into your physiology. So now you've just dug a little hole for yourself that you have to grow out of. Now, if it's just a movie, and particularly if you don't take the movie seriously, it's a tiny little hole. It doesn't amount to much. If you took that movie really seriously and you were one of those people screaming and sobbing and the rest of it, it probably affected you more, and it probably made more of a change in your physiology. Now, what about the child who happens to be with his parents when they get mugged and murdered on a city street? Does that affect that child? Yeah. And it's not just that his psychology is traumatized. He has a different brain structure now. It makes that the consciousness follows, the consciousness leads, the body follows. So the body then changes its state to match the consciousness. So if the consciousness is in a perturbed state, the body will modify to reflect that state. We have consciousness, and the body follows the consciousness. It represents us as we are. So the sheep learn moral behavior to take care of each other, and because of that, their brain changes and develops a little nodule over here, which is where that sort of processing takes place. So now see, that's a big one. We worry about our kids playing violent games and the rest of it. Well, it doesn't necessarily affect everybody in the same way. If you are not emotionally attached to it, and you see a horror movie, and you think the whole thing's ridiculous, and you laugh through it, but you think the girls are pretty, it's probably not going to create any problem for you. It's probably not going to make much of a change there because it wasn't a horrible experience for you. If it is a horrible experience for you, like your parents being mugged or even a horror movie, which you get emotionally involved in, it will affect you and it will change you. So there are people who see horrible things. What about people who are involved in wars and see horrible stuff? The soldiers who see and are interacted with horrible things. And they come home and they're changed. And it's not just psychology, but that psychology, that consciousness is reflected in the body. The body changes to express that. Your brain is an expression of your consciousness here. So as your consciousness change, that expression of your consciousness in physical form, it's a virtual brain, remember, in a virtual body. It's representing your experience here and you as an individual. So it changes to meet the consciousness. Consciousness is primary. The body's secondary. So that's why you have those connections between experience and lifelong things. It's not just, we have this idea of some kind of mysterious psychology, but that psychology is also mapped as part of our physical system. So there's a connection there. Okay, and that's the same way though that we grow in that same way. We do good things. We help people, we love, we care, we're involved, and that changes us. It changes us physically as well as spiritually. We grow and we become a little different. But that brain then is sort of like a record of what we've done here and what we've accomplished. And it can be horrific or it can be beautiful. And that's sort of the record. Now, if you have brain damage, if somebody, if your brain gets cut in half or some kind of accident happens or whatever, then part of that processing is no longer there and you lose that. Does that mean that your consciousness changes to reflect that? Of course, your consciousness isn't driven by the physical. That doesn't change the consciousness entity. It just means that now your ability to express that consciousness is limited here, because now you only have, say, half a brain. So you can't, it's the same with your computer. You take your computer and you chop the RAM in half. Well, your computer is limited, right? It only got half the memory. It can't do what it used to do. It's physically limited. So there are physical limitations. But it's the consciousness that leads. So that's another area that this sheds light on. So here we have a theory. We've derived relativity. We've derived quantum mechanics. We've shown why light has to be constant. We've shown why particles have to be probability distributions. We've explained this backwards causality and a lot of other things. And it explains the paranormal and healing and precognitive dreams and all the other things. They all fall out of this as logical conclusions, logical things. Okay, so what makes a theory valuable? Well, number one that actually counts in this reality is that it supports the current scientific beliefs. But of course, we know that's not what makes a theory valuable, actually. It just is the practical reality that we live with. What makes a theory valuable is that, one, it explains what's known. It has to explain what you already know. It has to have as few assumptions as possible. If you have to have lots and lots of assumptions to prop up your theory, then your theory is not fundamental. It needs to be elegant. It needs to be just a few assumptions. It has to explain what is unknown. It has to explain something new, otherwise it isn't better than what you had before. And it has to be able to be verified that those new things it explains are indeed fact. Okay, so basically we've done all that. We've explained science, we've explained the paranormal, we've explained a lot of the metaphysics, that kind of thing. So that's kind of where we are with this.